Hello, everyone. Today we will talk about Dynamics 365 Field Service, specifically about Resource Scheduling Optimization, RSO. The RSO module is what allows for automatic resource planning, essentially on autopilot. It's quite powerful, although it has its limitations. We'll also discuss the new AI enhancements from Microsoft in this product, real use cases of schedule automation, what RSO cannot do, and licensing. Let's start with the basics. Field Service. The core of Field Service is its scheduling calendar. Here we see a standard Gantt chart displaying resources and their schedules, indicating who will be working where in the upcoming days. These bars represent the travel time for each person. These are test data, so nothing confidential here. For example, we see that a certain job might take nearly 12 hours of travel time for just 1 hour of work. I'll explain the details later, such as why some tasks have no travel time, which is a separate issue. At the bottom, we see all the requests received over any given period. We can manually press Find Availability, which will show us which resources can be assigned to a particular work order. When we select any of these availabilities, filters appear automatically. Filters can include not just service territories, but also characteristics like fire safety certifications, special equipment installation skills, and more. You can also set criteria like customer ratings, selecting only 5-star employees if needed. For simpler problems, different levels of expertise might be appropriate. And here, we have the calendar. What is the purpose of all this? The goal is to ensure that, ultimately, the user or engineer has a clear picture, or perhaps it could be about delivery. The resulting picture is that they just need to go to the next point and know exactly what to do. In other words, this whole mechanism is designed for such a simple task. As usual, to make something simple, a lot of complex work is required somewhere. So, let's move on. The first method is, as I mentioned before, the add-in for Outlook. You have probably seen various add-ins. One of them can parse any email and automatically convert it into a work order. It tries to understand the content and then creates the work order. You correct it, press save, and it gets sent. The work order is successfully created. For those who haven't seen it, there is a sidebar panel in Outlook. We all have various add-ons that can integrate with Teams or other applications. This add-in works similarly. They also have a work order recap. It lists what is in the work order, what requests were made, and what happened. For instance, if there is a long history of communications before the work order was formulated, the work order recap will describe in a window what was discussed and what transpired. Next, let's continue with real-life cases. A client, during various discussions, mentioned several requests that turned out to be quite complex. The first one is about resources being in different cities during different weeks. For instance, in their case, they form a team and send them to a hotel for a week. They handle tasks such as moving from Houston to Atlanta, where they work on various sites, conducting installations and inspections. The following week, they might be in another city, and a week later, in yet another one. This type of planning is quite intricate because the teams are constantly migrating. Another issue raised was what happens if a new case arises, especially considering they might have many teams, up to 1,000 or even several thousand. How will the planning be handled? What are the constraints and so on? Because everyone is constantly on the move, some sites become closer for some teams and farther for others. Will they be able to manage it in time? When you have a vast number of resources to manage, it appears to be either an unsolvable problem or a very complicated one. We will also discuss and examine how to manage thousands of teams or how the system handles thousands of teams. Next, we'll discuss setting work limits, such as the amount of work that can be taken on in a day. How much work a resource can handle in a day. Let's start with the first point about resources being located in different cities. For example, we might spend 1 week in one city and another week in a different city. The interesting thing is that all resources have their own starting position. There can be 7 types of resources. The most common one is a user in the system, but it could also be contacts, like an external contractor, accounts, organizations, teams, equipment, or pools, which are different categories. Let's start with a simple example. A user. We see the user's address, and the system automatically determines their coordinates. For planning workloads, it's crucial to set the start and end locations. As we see, the resource address is set as the start and end point. However, this can also be an office or an organization unit. I can change it here, and the system will recognize the organization unit as the start position. This could be an office, a warehouse, or another point. Alternatively, if I set it as location agnostic, it means that the specific location doesn't matter, and we won't account for the travel time of that resource. We have 3 options here. However, there is no option to set a start time that changes weekly. For instance, there is no parameter to indicate that the resource will be in a different city next week. Microsoft's current recommendation is to change the address if you want the resource to be in Atlanta next week, for example. This is inconvenient because changing the address will make the system think the person is already in that new location, resulting in an inaccurate schedule. We needed a solution for this problem, and we found an interesting approach: setting the start and end positions through hard booking. In this case, we set the location to, say, Atlanta, and all planning at that time will be based on that point. This is the standard functionality. This is the start location. The end location is part of its standard functionality. It doesn't have a parameter to set time frames. It is always current. Now, let's talk a little about a different solution. If we want to send a person for a specific time, we need to create a separate entity to store these time parameters. This entity will need to create a start location for each resource based on the coordinates we set. In the calendar, a slot will be booked, whether for 5 minutes or an hour, indicating that the person will be at that location during that time. A fake work order will be created to fix the geographical location so that when the system plans, it starts from this point and not from the home location. Yes, it's a bit of a workaround, but an elegant one that ensures the rest of the functionality works properly. Otherwise, it's quite challenging to delve into the custom Microsoft features. So, let's assume we've figured out how to do this manually. Now let's talk about RSO and how the system can automatically analyze and process it. To understand this, we need to explain what RSO is. We're diving into the system. RSO appears in the system as a separate application. It's called Resource Scheduling Optimization and has its own menus. But the key point here is the schedules that will be managed. Here is our schedule. It has statuses like Publish and Run Now, indicating its current state. You can see the list of completed tasks. But what's key here? The critical aspects are the boundaries within which it operates and the goals it aims to achieve. For example, we might want to maximize the resource's working hours, not necessarily a person, or minimize travel time. The system will select the most optimal travel times. Another important aspect is the scheduling frequency, specifying how often a job should run. We can set it to run every 4 hours after the job has completed. It operates within this 4-hour window and then waits to start again. You can set any parameter, such as once a week or even more frequently. You can also define how long the job will run. The most crucial elements are the operational boundaries and goals. Let's look at the boundaries. First, it shows which resources we will select from. This is a system view list that displays specific resources. For instance, resources only in Atlanta or Houston. You can create a custom view or use an existing one to match your parameters, similar to Advanced Find, where you can set any parameters. Each job will only consider these resources and distribute tasks accordingly. An interesting point is how conflicts are handled when the same resources are reassigned, but that's another issue. In this case, I selected all available active bookable resources without any specific ties. You can set characteristics and other parameters as needed. Next are the requirements, or work orders, which are requests from clients for specific tasks. I selected all client requests. You can filter these, for example, by request type, location, or specific resource requirements. These are the standard options. I chose Valid Requirements for Optimization Engine. You can check resource requirements here, but I won't switch to that view now. Next, Since this system not only plans but also optimizes, we inform it about the existing bookings. Again, using Microsoft terminology, the system will optimize the scheduled tasks, bookings. What does this mean? It will look through the list of created tasks. Whether they were created manually or automatically, it doesn't matter. The system will review the entire list and start assessing who can be rescheduled if necessary, such as for logistics or transport tasks. It will calculate the most efficient way to allocate resources. The system will also consider the status of these tasks. For example, we can specify that if a task is completed, it shouldn't be moved. If it's scheduled, it can be optimized. For tasks in progress, we can set a status of "Do Not Move." Similarly, canceled and traveling tasks can be specified. We can also add additional statuses and parameters as needed, making the system highly customizable. The next important aspect is the range, which is crucial for planning. The key point here is using job current time. Instead of looking at the next or current day, we check the current time and then apply the range offset. For instance, if the planning is set to occur in 5 hours, the system will schedule the next available window. This interval can be set to any length, such as days, regardless of the time frame. Range determines how far ahead we plan. If I set it to 17 days, for example, and a request comes in for a task on January 5th or perhaps the 20th, the system will check and understand if it falls outside the 17-day planning period. If it does, it won't schedule it. It will simply show that nothing has been done for that specific requirement when it finishes the current task. Let's go back. The next point is the goals. That is, what is the purpose of this schedule? We're telling it. Number 1 priority is to maximize work hours. Number 2 is to schedule as early as possible. These can be removed or deleted. There are a couple more options that can be added. But again, this is all standard. We can't choose here. It's just a drop-down of the goals we can set, like minimizing total travel time and so on. For example, this goal can have certain limits added, like schedule within working hours, matching characteristics, matching territories. There are many options. For simplicity, I removed all constraints. These values are hard-coded, so we can't add or change anything here. We can't set priorities, but we can vary, for example, this schedule to optimize travel time. Another schedule might focus on something else. However, keep in mind that they can overlap and shuffle the work around. Be careful with this because the number of jobs can be unlimited. Let's move on. Now that we have set all the parameters and executed, let's see how this request performed. We can see that among the bookings, the system has automatically updated some. It recalculated the time, for example, if new resources or requests appeared. It automatically recalculated, but left some unchanged. Why? We need to check the schedule to understand. Maybe it didn't find a resource for this schedule. It can still offer our schedule. This is what I wanted to show you. Now, let's go back to the cases. What will happen if the system recognizes and automatically understands that if new bookings appear, and we see that this person, for example, was planned, but will be working in another location next week, the system will recognize these bookings. We'll set the value to "Do Not Move." There are certain filters, as we saw, that it won't touch. It will know that these bookings are hard-coded and will plan the load around these locations automatically. If there were work orders here, it will see that the resource will be in another place, making these irrelevant. They won't be included. You can set the travel time in miles, not in time, and if it doesn't fit, it will automatically shift the work to someone else. It will reshuffle everyone if needed and set new values. So if there was an existing schedule, it will just completely replan everything. Let's move on. What if cases appear throughout the day? We touched on this a little bit. The most important aspect is the planning horizon. It appears in any of these schedules. By opening the optimization schedule, you can access the schedule board. This shows how it views resources, the list of resources based on specified parameters, and the list of requests based on specified parameters. The key point here is the time range for planning. If a work order falls within one of these ranges, it will try to automatically fit it in. Again, there's no guarantee that it will find an available slot. Therefore, it might just keep the request pending until a certain time, and you might have to close it manually. Next, suppose we have 1,000 teams. There was an interesting request about this. Historically, the system could handle a maximum of 100 resources until 2017, which was quite limited. If it exceeded 100 resources, it started to malfunction. Microsoft changed this in 2017, and now the limit is 1,000 resources. However, I haven't seen any more updates on this. The maximum limit is now 1,000 resources. But how does it work now? It is divided into several phases. The first phase involves setting parameters to specify the required resource. The system then provides a list of the top N resources, which you configure based on your needs. For example, if we set a maximum of 1,000, it will return resources that match the characteristics, location, and so on. Even if there are 5,000 matching resources, the system will return the first 1,000 and then proceed to Phase 2, which involves finding combinations and working hours. Each resource might have its own pattern, such as time off, etc. So it calculates this only for 1,000 resources in the second phase. Why is this? Probably because it's impractical to calculate for an unlimited number of resources, and performance likely suffers significantly. So they imposed this limitation. Honestly, 1,000 is a workable number for a small segment. It's likely more than most need. Even if a client has 1,000 teams working, it will still be within a specific segment or service territory, so there won't be 1,000 candidates. There will be around 100 or so. Again, there are different certifications, satisfaction levels, and so on. Another case we were asked about is whether the maximum limit could be set to 2 or 3 jobs. Currently, this is probably the simplest of these requirements. It's about setting the duration of the job to 3 or 4 hours. In such a case, the system will not suggest booking for an 8-hour slot or more. Why is this important? There's a separate issue of capacity, but each work order is represented by a time interval. Therefore, the system is designed to revolve around hours rather than the number of tasks a resource can complete in a day. Regarding RSO, it's important to discuss not just what it can do, but also its limitations. A crucial point is what this planning engine cannot do, as illustrated by the numerous invalid entries seen in the previous slide. This list represents what the system cannot perform. One of the main limitations is group requirements. For instance, if someone needs carpet cleaning at home, it's not enough to just have a person. You also need a vacuum cleaner or some more advanced equipment. This means you need 2 resources available at the same time, which is known as group requirements. While it might be simpler if one person had one vacuum cleaner, if there are different people using different tools, this becomes a group requirement. You specify in your request that you need both a person and a vacuum cleaner, but RSO does not support planning for group requirements. When it encounters a request involving group requirements, it simply marks it as invalid. Another limitation is with crews. Teams have been added, but they must be location agnostic. Manually, a team can have its own address, which is often the case. We might have a team with a specific location and working hours, such as a temporary team for Atlanta, available only from the 19th to the 23rd. We can see who is part of this team, designate a team leader, and so on. It's crucial to understand that we can use the resource address, meaning the planning is based on the location of the team members or the organizational unit's location. For example, it could be an Atlanta hotel. However, if we change this parameter in resource scheduling optimization, it won't recognize it. This is because the optimization task becomes too complex for the system. A classic example is having 2 trucks, one with 3 employees and the other with 2. If a team goes to a site where only 2 are needed, the third person becomes underutilized. RSO doesn't understand how to optimize this third person's work, so it simplifies by only managing the entire team as a whole. The team goes to a site regardless of whether the third person will be underutilized or not. In addition, RSO, resource scheduling optimization, will only assign you work orders that are also location agnostic if you choose to assign teams. This means that typically, if you have a work order, you have an address to go to. However, in such cases, RSO, which is an automatic scheduling system, won't function properly, and it will require you to specify that the team's location doesn't matter. Essentially, it does not solve the transportation problem. Therefore, there's a restriction that teams must be location agnostic, and consequently, work orders for such teams must also be location agnostic for it to work properly. As a workaround, you can use service territories to ensure teams are assigned correctly, preventing scenarios where a team would need to travel across the country. This acts as a characteristic filter, ensuring the right teams are assigned. Moving on, there's another question about licensing and saving on licenses. RSO has quite a unique licensing model. This module is sold as an add-on for field service. It's not part of field service and needs to be purchased separately if you need automatic scheduling. Manual scheduling does not have these restrictions of location-agnostic teams or group requirements. You can plan manually without issues. But these limitations apply only to RSO, the automatic solution. If manual scheduling works for you, you can do it manually. However, if you have 1,000 teams, manual scheduling seems like an unrealistic or very lengthy task. RSO is purchased as an add-on in the same way as field service. It costs around $30, and licensing is per resource being optimized, not per user. For instance, if you have 1,000 resources, it's $30 multiplied by 1,000. If you have 5 resources, it's $30 multiplied by 5, regardless of the number of field service users. Resources can be a team, user, contact, or account. However, if resource scheduling optimization for a resource is set to no, it is not considered a resource and does not require licensing. That's basically everything. Thank you all. I hope this was helpful.